All right, this is section 14.3 on Hamilton paths and Hamilton circuits. What you'll learn in this section is you'll understand the definitions of Hamilton paths and Hamilton circuits. You'll be able to find the number of Hamilton circuits in a complete graph. You'll understand and use weighted graphs. You'll use the brute force method to solve traveling salesperson problems and use the nearest neighbor method to approximate solutions to traveling salesperson problems. All right, so let's say we're trying to find the best way to deliver packages around town, or we're planning the best route by which to run a series of errands. That can be modeled and solved using paths and circuits that pass through each vertex of a graph exactly once. Okay, so Hamilton paths and circuits. A path that passes through each vertex of a graph exactly once is called a Hamilton path. If a Hamilton path begins and ends at the same vertex and passes through all the other vertices exactly once, it's called a Hamilton circuit. When it comes to Hamilton circuits and Euler circuits, a graph can have one or the other, or both, or neither. So it's kind of one of those things, it's a little complicated there. Now, the graph on the right here has many Hamilton paths here. So we could do from A to B to E to C to D, or we could go C to D, E, A, B. It doesn't matter. However, it has no Hamilton circuits. Now, regardless of the starting point, it is necessary to pass through vertex E more than once because we're going to always go through that because whether we go down here or we're going to come back up here to get from this side to get down to get back to A or D or whatever, you're going to have to cross through that more than one time to get to the starting point. Okay, so that's why it's no circuit for it because you can only go through the same vertex only one time. So let's look here. So it says for the graph in the figure below, find a Hamilton path that begins at vertex C for the graph. And then part two is find a Hamilton circuit that begins at vertex C for the graph. All right, so we're going to start up here at E and we'll hopefully circle it. And we're just going to work our way through. Now, we can each vertex only one time. So let's start down and just go down here. And then maybe, I don't know, let's go down here and then down here, down here. And now we have to hit F, but we also have to hit C. So let's go here to F and then up to C. So that is a path. And a path meaning it's not coming back to a circuit going to the beginning point. So our path would be E to A to B to G to D to F to C. Okay, so that would be a Hamilton path. We hit each of the different vertices. Okay, now what's going to be different to make it a circuit? Well, we have to get back to E. So the key here is we're going to go one more step and we're going to get back to where we started. Okay, and when we do that, now we have E to A to B to G to D to F and to C. Okay. And now we go that one last step and we have E. And now we've completed the circuit. Okay. So that's how we have to do that. All right. Now let's pause there and we'll come back for more.